बिस्मिल्लाहिर्रहमानिर्रहीम। रब्बिश्रह ली सदरी व यस्सिर ली अमरी वाहलुल उक़दतम मिन लिसानी यफ़क़हू क़ौली। Assalamu alaikum. Let's consider the case. The person is standing on the chair. The height of the chair is 0.5 meter. The person jumps from the chair to the ground. The distance covered is 0.5 meters. Let's calculate the time taken to cover the distance of 0.5 meter, that is the height of the chair, under the acceleration due to gravity, that is 9.8 meter per second square. X is equal to ut plus half at square. X is equal to 0.5 meter, that is the height of the chair. U is the initial velocity, which is 0. A is the acceleration due to gravity, that is 9.8 meter per second square. If we substitute the value, we find that the time is equal to 0.319 seconds. Let's calculate the final velocity when the person approaches the ground. V is equal to u plus at. U is the initial velocity, which is equal to 0. A is the acceleration due to gravity, that is 9.8 meter per second square. T is the time taken to cover the distance of 0.5 meter under gravitational acceleration, that is 0.319 second. V is equal to 9.8 meter per second square multiplied by 0.319 second, giving us the velocity of 3.13 meter per second. Therefore, when the person is close to the ground, the velocity is 3.13 meter per second. When the person is at the height of 0.5 meter above the ground, the energy is stored in the form of the gravitational potential energy. Gravitational potential energy is equal to mgh, where m is the mass of the person, that is 60 kg. G is the gravitational acceleration, that is 9.8 meter per second square. H is the height the person is above the ground, that is the height of the chair, which is 0.5 meter, giving us the gravitational potential energy of 294 joules. When the person jumps from the chair, the gravitational potential energy is converted into kinetic energy. Kinetic energy is equal to half mv square, where m is the mass of the person, that is 60 kg. V is the velocity when the person approaches the ground, that is 3.13 meter per second, giving us the kinetic energy of 294 joules. Therefore, potential energy is completely converted into kinetic energy, giving us the law of conservation of energy. The law of conservation of energy states that the energy cannot be created nor can be destroyed, but can only be converted from one form to another. It requires 375 joules of energy to break a bone. When a person jumps from the chair, the kinetic energy as he approaches the ground is 294 joules. Hence, it is safe to jump from the chair of height 0.5 meters. Let's consider the case that the person jumps from the building of height 3 meters. X is equal to ut plus half at square. X is the height of the building, which is equal to 3 meters. U is the initial velocity, which is equal to 0. A is the acceleration due to gravity, that is 9.8 meter per second square. We calculate that the time taken to reach the bottom of the building is 0.78 seconds. V, which is the final velocity, is equal to u plus at, that is final velocity is equal to initial velocity plus acceleration into time. The initial velocity is 0, acceleration due to gravity is 9.8 meter per second square. The time taken to reach the bottom of the building is 0.78 second. Therefore, the final velocity is 7.668 meter per second when the person approaches the ground. When the person is 3 meters above the ground, that is on the top of the building, gravitational potential energy is equal to mgh, where m is the mass of the person, g is the gravitational acceleration, h is the height of the building or the distance the person is above the ground, giving us the gravitational potential energy of 60 multiplied by 9.8 multiplied by 3, which is equal to 1764 joules. When the person jumps from the building, the gravitational potential energy is converted into kinetic energy. Kinetic energy is equal to half mv square. M is the mass of the person, that is 60 kg. V is the velocity as the person approaches the ground, that is 7.668. therefore giving us the kinetic energy of 1764 joules. We notice that the potential energy is completely converted into kinetic energy, giving us the law of conservation of energy. Energy at the height of 3 meters is 1764 joules. That is a lot greater than 375 joules, which is the energy for the bone to break. Hence, it can cause bones to break. Let's consider the case that the person jumps from an aeroplane that is at the height of 5000 meters. After covering 4000 meters, the person opens the parachute when the person is 1000 meters above the ground. There are two forces at play here. One is the gravitational force, the other is the air resistance. When the person jumps from the parachute, initially the gravitational force is greater than the drag force. As the velocity increases, the drag force also increases. A point is reached when the gravitational force is equal to the drag force. In this case, terminal velocity is reached. Once a person opens the parachute, because of the area of the parachute, the drag force increases considerably. The velocity decreases because of the drag force, and a point is reached when the gravitational force is equal to the drag force again, and the second terminal velocity is reached. Drag force is equal to half rho CAV square. Rho is the density of air, C is the drag coefficient, A is the area, and V is the velocity. Let's consider the case before the parachute is open. Density of air is equal to 1.21 kg per meter cube. Drag coefficient C is equal to 0.7. Area before the parachute is open is 0.18 meters square. We need to consider the case when the first terminal velocity is reached. In this case, the gravitational force is equal to the drag force. Ft, which is the drag force, is equal to the gravitational force, that is mg. Drag force is equal to half rho CAVT square, which is equal to mg. We need to find Vt, that is the terminal velocity that is reached before the parachute is open. Vt is equal to under root 2 mg over rho Ca. M is the mass of the person and the parachute, that is 80 kg. G is the gravitational acceleration, that is 9.8 meter per second square. Rho is the density of air, that is 1.21 kilogram per meter cube. C is the drag coefficient, that is 0.7. A is the area before the parachute is open, is 0.18 meter square. We calculate that the terminal velocity is equal to 101.4 meter per second. Let's consider the case when the parachute is open. In this case, the coefficient of drag CD becomes 1.36. The density of air rho remains the same, which is equal to 1.21 kilogram per meter cube. The area increases greatly once the parachute is open. The area is equal to 50 meters square. Mass of man plus parachute is equal to 80 kg. We need to find the second terminal velocity when the drag force is equal to the gravitational force, that is Ft is equal to mg. Drag force is equal to half rho CAVT square, which is equal to mg. We need to find the terminal velocity, which is equal to under root 2 mg over rho Ca. M is the mass of the person plus parachute, that is 80 kg. G is the gravitational acceleration, that is 9.8 meter per second square. Rho is the density of air, that is 1.21 kilogram per meter cube. C is the drag coefficient, that is equal to 1.36. A is the area once the parachute is open, which is equal to 50 meters square. We calculate that the terminal velocity is 4.36 meter per second. Let's study the velocity time graph. Initially, the gravitational force is a lot greater than the drag force, therefore velocity increases. Since the velocity increases, the drag force also increases since drag force is proportional to v square. A point is reached when the drag force is equal to the gravitational force. In that case, terminal velocity is reached. The first terminal velocity has a value of 101.4 meter per second in our case. Then the parachute is open. The area of the parachute causes drag force to increase greatly. Since the drag force is greater than the gravitational force, the velocity decreases. Because the velocity decreases, the drag force also decreases. A point is reached when the drag force is again equal to the gravitational force. In that case, we say that the second terminal velocity is reached. The value of the second terminal velocity in our case is 4.36 meter per second. The area under the velocity time graph gives us distance. Distance before the parachute is open is equal to half into 20 second multiplied by 100 meter per second plus 30 second multiplied by 100 meter per second, giving us a distance of 4000 meters. After the parachute open, distance is equal to half into 95 meter per second multiplied by 5 second plus 4.36 meter per second multiplied by 175 second, giving us a distance of 1000 meters. Therefore, the distance covered before the parachute is open is 4000 meters and distance covered after the parachute is open is 1000 meters. From the velocity time graph, we can determine the distance time graph. Since the area under the velocity time graph is distance, when a person jumps from an aeroplane that is 5000 meters above ground, he covers 1000 meters in 20 seconds under acceleration, 3000 meters in next 30 seconds under constant velocity, 250 meters in 5 seconds under deceleration, 750 meters in 175 seconds under constant velocity. The slope of distance time graphs gives us velocity. We notice from 20 second to 50 second the slope of distance time graph is constant. Hence velocity is constant, that is the region of the first terminal velocity. We also notice that the slope from 55 second to 230 second of distance time graph is also constant, that is the region of the second terminal velocity. The slope of the distance time graph from 20 to 30 second is a lot steeper than the slope of the distance time graph from 55 second to 230 second. This means that the first terminal velocity is a lot greater than the second terminal velocity. The slope of velocity time graph gives us acceleration. Hence, from velocity time graph, we can construct an acceleration time graph. When a person jumps from an aeroplane, initially the gravitational force is a lot greater than the drag force. Therefore, the person experiences a constant acceleration of 9.8 meter per second square, that is the free fall. With time, as the velocity increases, the drag force also increases since drag force is proportional to velocity square. When the drag force is equal to the gravitational force, the velocity becomes constant, that is the first terminal velocity. Since the slope of the velocity time graph is 0, the acceleration is also 0. When the parachute is open, the velocity decreases greatly, drag force increases greatly, which causes a negative acceleration of minus 19 meter per second square. Since the velocity decreases, the drag force also decreases since drag force is proportional to velocity square. Again, a point is reached when the terminal velocity is reached, that is the second terminal velocity. In this case, drag force is equal to the gravitational force. Since velocity is constant, the slope of the velocity time graph is 0, which means that the acceleration is 0. May Allah bless us all. Thank you for watching. Allah Hafiz.